Number 41. Develop an amortization schedule for 4-year car loan if $16,700 is borrowed at 8.2% compounded monthly. Okay, so we want to develop the amortization schedule. So that's going to generate this large table. First, we want to know what is given. So, given. The given information is the amount borrowed. That is $16,700. We have the length of the car loan in years, which is 4. And we know the current interest rate, which I'm just going to immediately write as a decimal, of 8.2%. Okay, and we know the compounding is monthly, so that's going to mean 12. Okay, so this is the given information. And need to find, in order to do this, so we need to find the following. We need the payment, we need the period interest, and we need the number of payments. So the period interest is the annual interest rate divided by the compounding. The number of payments is the length of the loan in years times the compounding. And the payment can be gotten in a couple of ways. I am going to use the present value formula for a ordinary annuity right now. So that is the total amount divided by the terms in the brackets. So that stuff divided by the period interest, and we have 1 minus 1 plus period interest raised to the negative 48th power, which is the number of terms. That should be good. It is. Okay, so we're dealing with a loan. So this should be rounded to 2 decimal places because this is money and this is money. But I'm going to leave that alone for right now because I want to show some things that happen with this. Okay, so the strict things we need for the amortization table are beginning balance, payment, interest, and ending balance. No, we have period reduction, and ending balance. Okay, so these are the headings you need for the typical amortization table. You can also possibly get away without using beginning and ending, but I think it makes it clearer if you have the beginning and ending balance. It's also a good idea to have an index here for the particular period you're talking about. So this is just an index, and so I'm going to fill that in first. So it starts at 1, and then we want to add 1 to this. There's a few ways of doing that. I'm just going to do it this way. Yeah, that's too many. It should be enough, and then we need 48 of these. Okay. So those are the period indexes. Now the first beginning balance, you use the starting loan amount, so that's going to be that. The payment is this payment here, which is going to be fixed. So you want to add the dollar signs. I did that by cycling through F4. Alternatively, you could also just type in the cell reference or add them manually. So $3. We need the interest. So the interest, as we drag this down in a short while, we're going to want this to update this reference. So the interest is the current balance, which is the beginning balance of the period, times the period interest. And so when we drag this, we want this to update, but we don't want the period interest to update. So we need that one to be frozen with the dollar signs. The period reduction, maybe I should rename that in a second. That's going to be payment minus interest. Okay, and the ending balance is your beginning balance minus period reduction. Okay, so that's the first row. For the second row, this beginning balance is your prior ending balance, and then these other formulas just get dragged. Okay, and then we take them and drag them all the way down. Okay, so this is the beginning balance of the period in this column. These are the payments, which are fixed here. This is interest. This is the period reduction, which is payments minus interest. And then this is the ending balance, which is the beginning balance minus the period reduction. Just to show the formulas. There they are. Let's go back. Okay, so let's go down here and see a few things. So you'll notice that is 3.9 times negative 3.9 times 10 to the minus 10th. That's a really tiny number. So this is effectively 0. And that's just due to some machine rounding errors. But you'll also notice in this payment we actually have a lot of decimals here. And same thing with the period reduction. So what we really need to do is round this payment. So I'm going to do that on right next to it. So that will round it for us. And then we want to change this reference to this one. Okay, so that's updated. We also need to round the interest. So that also needs to be rounded to 2 digits because this is, we're talking about money here, and so you can't have something less than 1 cent. You have to charge that interest. Okay, so we've updated those two, and so we're going to drag this down, and then now drag it all the way down. Okay, and so you'll see this. We now have overpaid. That's what this negative means on the balance, by 26 cents. So if that bothers you right now, and you just want to decrease the last payment by this amount, right? So then it's zeroed out. So what actually has to happen, that's due to some accumulating rounding error in rounding in this. So, and then these are all money. So let's just reformat that. And we want this as currency to 2 digits. Okay, so those are all money. So now it's 0. The way this is handled is you adjust some of these payments internally by 1 cent, or you can just adjust the last one. So it's important to be aware of that there's some internal rounding that accumulates because of how the interest was. Remember, when we didn't round these, we ended up with 0 here without having to adjust this last payment. But because we're talking about money and the payment has to be charged to, a cents digit, you have to have rounding, and so that does affect some of these values in here. The simplest way is just to adjust the last one. You can also adjust some of these other ones by 1 cent internally. There's also an Excel function to calculate this. So I just want to show that now. That's called the payment function, it's PMT. And so what it's going to take is the period rate, the number of periods, and the present value. So that is the amount you're borrowing on the loan. And you'll notice that this generates the same amount that we calculated here after we rounded it with this formula. So that's all it's doing. It's also making it negative. So depending upon how you want it, you may want this to be a negative value or not. Depends on the specifics of what they're looking for. But this is the general setup for an amortization table for a loan. You want to make sure that you have beginning balance, say what the payment is, say what the interest is, say how much the beginning balance is going to be reduced by, and that's simply payment minus interest is the amount applied to the principal, and it goes down. Okay, a few more interesting things here. If we want to know how much interest is being paid here per each year, you can do this. Yep, okay. And then same thing with this one. So that's the interest on the first year. This is the interest on the charge in the second year. So months 13 through 24. And then do the third year, months 25 through 36. And then do the last year, which is 37 through 48. This is just so you see what's happening to the interest. So the total interest, this is useful to know what these are. And so you want to know this in general for yourself if you're trying to do calculate a car loan, etc. You're buying a car or a house, and you want to know what your total payments are. Is useful. You could also find this just by multiplying the payment amount calculated up here by the number of periods. But if you adjust any of these, and you may want, like if you pay a little extra or something, you may want to put that. You may just want to do the direct sum here. So you're paying an extra $3,000 almost for this car that you purchased, and by looking at the partial annual sums of the interest, you can see that most of the interest is charged in the first 2 years, and then in the second 2 years, the third and fourth year, the interest drops way down, and you see that the principal. That's because you're applying more of your payment to the principal reduction rather than interest after this year. So you're at $64 in interest, and here you're almost double initially on the interest. So, and that extra amount you're applying to the balance reduces the total interest you're paying. This is relevant for things like a house. It's also relevant for a car, but usually because the car is a smaller loan and it's shorter, it doesn't matter as much. But for a longer purchase like a mortgage or student loans, this does matter. Okay, so that's it.